Okay. So we'll look at the rest of the review questions and practice problems. Review question, let's see, 10 says if an atom absorbs energy, what happens to its electrons? So if an atom absorbs energy, electrons move from a lower energy state to a higher energy state, from a lower energy orbital to a higher energy orbital. And if an atom is emitting light, what are its electrons doing? So they are returning to orbitals that are closer and closer to ground state when they're emitting. They emit light to give off energy to go back down to a lower energy orbital. 11 says, what is the concept of ground state and why it's so important? Electrons are at their lowest energy level when they're in ground state. They fill the orbitals from low energy to high energy in order. And the importance is that that's where all matter wants to be. Low energy just drives all chemistry and physics. Everything wants to be at the lowest energy state it can. In fact, I always just call it being on the couch, right? You guys know after you work really hard, you just want to come home and sit on the couch. Maybe some of you don't, but that's what I'm going to do right now. I'm so tired. But the couch is like the low energy state. Everything wants to get back to the couch, back to ground state. Number 12 says, the three fundamental particles that make up the atom are the proton, the neutron, and the electron. Order them in terms of decreasing mass. Well, here's where we get all confused for me. So decreasing mass, so big and then down to little. So the biggest of the subatomic major particles is the neutron. It's the biggest one. It's actually made of a proton and an electron, and then they can break apart in a nuclear situation, decay, radioactive decay. And then, so neutron's the biggest, proton's the middle, and electron is much, many orders of magnitude smaller than either of the other particles. Right, the neutrons and protons are in the nucleus. So the nucleus is a positive charge. The strong nuclear force holds that together because positive things want to repel each other. And the electrons orbit in their orbitals. The s orbitals, sphere, p orbitals are the dumbbells, and the d orbitals fit into the spaces that the dumbbells kind of leave for them. So you have the s's, you have the dumbbells kind of in there, and then the D's around. So it's kind of, if you look at pictures of them, they're very complicated. And they also, orbitals can hybridize to keep everybody like the same energy level. So this is not the whole truth, once again. But it'll help you learn the rest of the truth. It's just a building block until you have enough math to understand the rest. So it's good, it's just not everything. So, practice problem 7 says, one electron is in a 2p orbital and another is in a 3s orbital. Which has the higher energy? So, let's see if I can mark where this should go and move the camera. I hope that'll work. Alright, so if you've got one in a 3s and one in a 2p. Alright, so here's 2p, let's see, 1s1, 1s, or 2s1, 2s2, this is 2p here, and then moving on down, you get to 3s. So 3s comes after 2p. What these boron, carbon, these guys are the 2s orbitals, and then later on in the periodic table here, sodium and magnesium, their last electron is in a 3s orbital. So 3s is the higher energy. Let's see. Put this back. I really hope it's aimed right. Number 8 says, number 7, and this brings up a good point. This test has questions that have multiple parts, and I almost skipped the second half of 7. And many students in the past have skipped pieces of questions on this test, so be careful to keep reading. So the second part of 7 says, what shape is each electron's orbit? Okay, so 3s would be spherical orbits. There's 1s, 2s, 3s. And then the 2p orbital would be one of these dumbbells, like two balloons stuck together is one of the p orbitals, and there are three, holding 6 electrons, so like dumbbell shaped. So 8 says, give the full electron configurations of the following atoms. And A is Ti, which I hope is titanium in my super tired state. You don't know. Okay, so titanium, I'll locate it on the periodic table here. I'll bring it. Oh, my cup is a periodic table. How fun. So we locate that. Probably should have done that before. Okay, it's got an atomic number of 22. So come on in here and look. It's right here on the periodic table. So I can already tell you its last electron, right? We know D's, the first set of D's, this first line of D's is going to be 3D. This 3D1, 3D2. So I can already tell you right now, maybe I can aim here, that we're going to end in a 3D2 orbital. Right, so I can just go through the periodic table here. I wonder if I can. I hope this video is not nauseating. So I've got 1s1, 1s2, 2s1, 2s2, 2p1, 2, 3, 4, 5, 6, 3s1, 3s2, 3p1, 2, 3, 4, 5, 6, then 4s1, 4s2, 3d1, 3d2, and we're there at titanium. So we'll write 1s1, 1s2, 2s1, 2s2, 2p6. Oh wait, I don't have to do that. I'm like so beyond tired. I can just do 1s2, 2s2, right? Is that true? Okay, good. 2p6, 3s2, 3p6, I don't have room, 4s1, 3d2, right, 4s1, 2, oh, not 1, 2, I'm too tired to make a video, I'm sorry, so I'll read literally off my paper, I hope it's what the board says. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. So what is on the board now, I hope you can see, is correct. Okay, that's titanium, Ti. Alright, the next one, B says S. So S is up here, atomic number 16, that's sulfur. Right, so it's going to end, this is 2p, this is 3p, 3p, 1, 2, 3, 4. So S is at 3p4 for the last one. So I just copied in. 1s2, 2s2, 2p6, 3s2, 3p. So now I'm in that last 3p, 1, 2, 3, 4. So now I'm at the end there. Sulfur is 1s2, 2s2, 2p6, 3s2,